Hello, dear colleagues. Thank you, Ruslan, for the announcement. So I'm happy to present my master's thesis, and let's start. So as Ruslan mentioned, I was advised by Alberto and Nazari. Many thanks to them. So this is the plan for this work. It's pretty common. So we will discuss the motivation related work, outline gaps and questions, then review the results for the experiments, derive some conclusions, future works, and then will be the Q&A session. So here's the problem statement. So nowadays, our models, like large language models, they become bigger, and cost for their training and fine-tuning, it rise. And still, the outputs are not always factually correct, and we have to verify them. And to solve this problem, we have to have editing methods for the large language models to edit facts there. And to improve these methods, we have to understand the mechanisms under the factual recall inside the model. So this is a quick recap of the motivation. So here is, you can see that GPT-4 training costs like more than 100 of millions of dollars. And also that large language models sometimes accuse people in things that they never did. And because of that, people struggle a lot. So here's the question for you. Do you trust the model's output, and will you trust it more if you will see that sequence number near the model name increase, like llama 2, llama 3? Is it like make it more trustable and more trustworthy? And how can you trust the model's output if you cannot understand how it actually retrieves the knowledge from its inner weights? So I will leave that question to you, and we'll proceed to related work. So we started, uh, I will try to answer that. So the related work we started working with, so first we examined the editing methods. So there were ROMI, and based on that MEMIT and PMAT. And those methods, they are actually working in that way that they determine the layers where the factual information is stored, and then they are editing the inner weights. And we were curious how they actually detect those important components where the information is stored. For that, the causal tracing method is used. This is the variation of activation patching. And its idea is to like intervene into the inner activations in the model and change some components outputs to understand impact of the change on the final generation, like impact on the probability of generation of some token. And there were also an interesting finding in the PMAT method, which called precision model editing for transformers, and they were editing not only multi-layer perceptrons, where we know that they are actually key-value memories, but they were also editing multi-head self-attention weights. And their idea there is that multi-head self-attention, it acts like a common knowledge extractor, and it still have some amount of factual knowledge, but it is like more concentrated in the MLPs. So we were working into that direction. We were working into the direction of the interpretability of the model. And this is the work that we were really backed up. This is the indirect object identification work, where researchers aim to answer the question how specifically model perform a task when it has to generate a name from the context. And you can see that they actually achieved to get the circuit. Circuit is the subgraph of the model computational graph, which is responsible for that task. And they found that there are attention heads that have specific tasks. Like, for example, we have this duplicate token heads, which try to identify if this token was there before mentioned in the context, and many other tasks. So this is only one circuit for the one task. So there are a lot more to uncover, and we aimed for that. So our research gaps are the next. Identified research gaps are the next. So existing fact editing methods, they are working only with the MLP layers. And even that PMAT, it is working with the multi-head self-attention blocks. They are not considering those attention head specific tasks. And knowing those factual recall mechanisms, those mechanisms that exist in the model, we can improve those facts editing methods and make them more efficient. We also don't know how this context memory conflict is resolved in the model when it is presented to the information which conflicts with what it specifically knows. So we define the next research questions, and we want to understand what is the role of multi-head self-attention in the factual recall, what are the mechanisms there, what role the multi-head self-attention plays in retrieving information from context, and also how the model solves this context memory conflict and what are the mechanisms. It is a common case for the interpretability research when we create a specific data set to test a task. So we reviewed existing data sets for the fact editing methods to understand what is there. We also checked the indirect object identification data set and came up with the prompt structure on the right part of the slide, where we picked geography domain and we are questioning the model where in which country the city is located. This data set consists from the two parts. First part is used for the experiments, and the second part is used to create average activation values to then use it in the patching methods. So our experiments will be the next. So first of all, we will conduct the experiment to understand the data flow and recall mechanisms for in-context learning approach. Then we will do the same for the factual recall. And then we will try to compare them to understand where is this context memory conflict is resolved. For that, we are using the next mechanisms like activation patching, path patching, and attention maps. And we were using the next libraries, Romy and Tensor and Transformer Lens developed by Neil Nanda and team. In this interpretability domain, there are no like common metrics like accuracy or F1 score. We don't have that, but we are working with the logics of the tokens. And to understand the impact of this patching or ablation on this logics, we use this logit difference metric, which is actually a difference between two logits. So first logit is the expected output, and the second logit is the base like token logit. So what does it mean? For the in-context learning example, that means that first token is that country that we are like changing the position for the city, and the second token is the actual factual country for the city. And to evaluate the impact of the component on the generation, we calculate the next metrics. So we calculate the cumulative ablation effect on the logit difference. And to understand how this component actually impacts the specific token generation, we calculate the cumulative ablation effect on the token logit. So let's proceed to results. So first of all, we started by reproducing the causal tracing approach from the Romy paper to Llama 2. We successfully did that. But the problem with that was that experiments on the Llama 2, they took a lot of time for us, and we had to spend a lot of time to analyze the results. Because our final goal was to understand the attention heads mechanisms. And in Llama 2, there are 32 layers and 32 attention heads, which by multiplication, we came up with more than 1,000 attention heads that we had to review. That is why we backed up to the smaller model, to the GPT-2, and never returned to the Llama 2 again. So this is the results of our first experiment that we done on the prompt with in-context learning and use the activation patching for that. So on the first row, you can see the cumulative ablation effect of the MLP block patching, and on the second row, the attention block patching. On the columns, there are on the left, like second appearance tokens position and last token position. And color coding here is next. So the component which is blue, it is actually promoting the edited knowledge or suppressing the factual knowledge. And the red is vice versa. So this color coding will be preserved in the next experiment, so we can like stick to that. So what you can see here, it's a little bit uh, hard, but I can show you the next and highlight the next fields. You can see that on the second token position, the MLP blocks on the first layer, MLP block on the first layer is really important. So this is the place, and it is supported by previous researchers, where the model constructs the representation of the subject that we are talking about. So on that position, it constructs the representation of the city that we are talking about, and we are asking where it is located. Oops. And here is the interesting thing, that on the last token position, right before the generation, MLP layers, they're also very important. But remember I said to you that we know that MLPs on the early layers, they store factual knowledge. So what is the purpose of, and what is the, like what those MLP layers are doing that on that position, and why they're active there? We like don't know yet, but it is left for the future work. But it actually shows that MLPs, they are not only storing the information, but also doing something else. And here is the attention block, which is really important in this task on the city mentioning position. And we wanted to investigate this importance. That is why we done activation patching for the attention heads and to understand the most important ones. So what we can see that on this subject second appearance token position, there are really important head on the layer 7. It is head 6, and it is also important on the last token position. So probably this is the model, this is the attention head that is actually getting some information from the context. So we tried to examine the attention pattern here, and I highlighted that on the slide. So this attention head is actually attending to the city and to the country that should be promoted. So this is showing us that we are on the right path. So let's review the next experiment. This experiment was performed on the prompt without in-context learning part, and yeah, and what we can see here that also first MLP layers, they are super important here because they are like constructing the representation of the subject that we are talking about. And here is also a couple of important attention blocks that we wanted to investigate. So we also did an activation patching for those attention heads on that token positions. And what we can see that as well, attention heads on the subject second appearance token position, they are like super important. And those like that we investigated on the last token position, that they are not so important, and they don't like play a key role there. But what those attention heads, they are doing there? So let's review the attention maps, and we can see that those attention heads, they attend to only to the city which is mentioned in the context. And we were kind of confused about that, because next attention head that we reviewed, it was also attending to the city. But then when we reviewed the same attention heads for our in-context learning part, we saw that they as well attend to the city and then to the changed knowledge about this city location. So we can say that those attention heads play a key role here. But Here are the results that we did after the master thesis submission, and I think that it is important to show them. So what we can see here, we try to examine them uh, by their impact on the specific token, and we can see that there are two classes of attention heads. So before this research, we knew that there is a specific class of attention heads which are suppressing the information from the context. But here we can see that there are also another classes of attention heads. So this class of attention heads, it actually only promotes the factual token logic because it's not like present on this figure. And this class of attention heads, it is promoting the factual knowledge and also suppressing the information from the context before it is present, because it is present on the left figure and on the right figure as well. So we uh, did also a pass patching here to understand which attention heads they are actually impacting the generation results through those models. And we found that it is attention head on zero attention head on the layer 0. And those attention heads on the 0 layer, they are helping like those first MLP layers to build representations and concatenate the tokens. So that is why we knew that those mechanisms are connected. So as the conclusion, we created a data set to work with this geographic task. We conducted several mechanisms to understand which attention heads are like important for those two tasks, and we located that the area on from layer 6 to layer 8, it is responsible for this context and memory information retrieval. But to understand more, we have to conduct more experiments, what is like going on there. And also our results align with other researchers in the field. So for the future work, we have a lot of things to do. So we have to restructure this circuit finding approach with pass patching to make the circuit more complete, because now I only showed you the specific attention heads, and we aim to do that as they show in the indirect object identification, like the complete circuit. We also want to research the representations that attention heads are writing, because now we only showed what they are like attending to, but we want to understand what they are writing. Also, we want to verify our circuit using the minimality and completeness criteria when we will, like, after structuring the experiments, get it. And also, we want to scale up to bigger models to understand the impact of the superposition phenomenon, as well as they present refined results to a wider audience. Yeah, so that's it. Thanks for your time and attention. Yeah, now it will be like Q&A session, but I wanted to quickly answer my reviewers' comments. So there was an important question if our data set is limited to GPT small, and if it could be used for another models. So in general, yes, it could be used on another models, and it is only verified on the GPT-2. So we advise, if you will use this data set, verify it on the model that you will be using. If it is a larger model trained on the bigger amount of data, it should work there. And also there was a question about this indirect object identification paper. So they were using like kind of prompts that doesn't make sense to retrieve this indirect object, but they never stated that it somehow impacted the ability of model to generate the output. And here, and they didn't use the causal tracing to like to understand and define the circuit. They used the activation patching, so there is no like noise tokens at all. Yeah, so that's it. Have happy to hear your questions.
Anyone would like to start?
Thank you for presentation. Very interesting. Uh, I'm looking at the review,
Mhm.
and I do see that the review has provided 7 critical comments.
Yes.
You have commented on the 2 only.
Yes.
What about the rest 5?
So I commented only on the questions that my reviewer stated about those another 7 critical like points on the review. It was very helpful to hear them, and I responded to my reviewer like with detailed comment on the each one. And probably, yeah, that is great that he spotted such things and advised some future steps to do. For example, to review this interpretability using the Ukrainian language or any other language to understand if it is language agnostic or not.
This was not only about language neutrality. uh, he also spotted some things in the thesis. For example, the stuff in figures 5.3 and 5.4.
Yes, yes, that was an issue because I like
Was it just a copy paste mistake,
yeah,
or
yeah, that was a pure copy
because
paste
I
mistake.
checked, and in the version of your thesis that we have at our disposal, there's no problem. Have you been given the chance to revise your thesis after the review's comments?
Yes, yes.
Okay.
So I
Okay.
changed those figures to the correct ones.
Okay. What about the conclusions in chapter 6?
Yes, I added there the conclusions before because there were no any.
Okay. What about the novelty criticism?
Yes. So the in our like in my thesis work, there were no clear statements about what I did myself and what I reproduced. But in my presentation, I tried to tackle this problem, and I specifically said that causal tracing and this ROMI application, they were reproduced on the Llama 2 because we never tried to invent something there. But about this activation patching that I did on the GPT-2, it was all my code. I delivered that. I also concluded those experiments, and
This criticism was not just about the intellectual property, but about the novelty. Do you think this patching approach is a novel approach? It might extend the state of the art in a way.
so this approach, it is used in the interpretability domain quite often, and it is yes, it is a state-of-the-art method to do this reverse engineering of the model. And what we did here, so in some way, um, it is interesting that we discovered the specific location between 6 and 8 layer for those attention blocks that are responsible for the context and factual recall. And hopefully that we will go into that direction, examining the attention heads, and we'll understand more how this whole circuit is working, and then we can present that and give the full picture of that.
So, please correct me if I'm interpreting what you have said in the wrong way. So, to date, the only novelty lies in the code implementation.
Not really, because we conducted experiments and we show those attention patterns for the models, and this is some kind of a new class which is not known before, and we want to work on that to understand how it changed its capabilities based on the task, because we had two tasks. One is changing the the information that the model is storing, another is not, and it is only trying to retrieve this factual information. And this class of the attention has, it is working both there, and it is changing its way of how it's working, like based on the task. So this is something novel, and as well as the location that those layers, they are pretty important for those tasks.
Uh, and perhaps my last bit is on dataset statistics. To somehow shown in the slides.
Not in the slides. I didn't show that. I only showed that. I can.
Could please refer to the page in the thesis?
Yes, but I added that to the thesis.
Where is it? Which page?
Oh, I don't recall. It is in the dataset section.
Okay.
There is a subsection about the dataset revisions, and probably at the end of that, there is a dataset statistics. I don't recall the page.
Thank you. Really interesting work and a lot of questions, actually. So, as far as I understand, to get this interpretability, you dive into the network and try to find the actual, not neurons, but like sections or groups where this, which correspond to this factual information you ask the network.
Not really. So we intervene into the model, and we try to find the mechanisms that are like promoting this information to the generation, because in the model there are no specific neuron or attention head which actually responds of storing some information. They are working in the super superposition phenomena, where they have more information to store and less dimensions. And for the bigger models, it even explodes. The more blocks you add, the more information it can store. And this is a huge problem in the interpretability domain, because we cannot say that this specific neuron, it knows, like, for example, every baseball player that we have in the world. We cannot say that. So it is acting in the superposition. So a couple of layers, they know this information. It is somehow distributed there. And like we don't know how yet.
So back to your result. So you find how this information promoted to the generational level layer, right? And so my next question is, so how many samples, with how many samples have you played?
So
So we here you showed us like two cases, with context and without it,
yes.
like very detailed. But in general, how many experiments have you run?
So this experiment was run on the dataset, and dataset, it consists of 100 examples for each experiment. And also there are 100 examples to create this mean ablation activation values to then intervene into the model.
And specifically on this slide, what do we see? Is it an aggregated result for whole this dataset?
Yes.
Okay, and then you like repack it and show us like one concrete example in terms of those. Yes.
Here I showed the one example, but we actually reviewed not only on one prompt. So we reviewed on the many prompts to understand if the attention pattern is actually the same for each prompt, and it is not like tied specifically to some.
Okay, and then it seems like you stop. So you make A, but do not proceed with B. I mean that you showed us, okay, there is a difference. We see how it started, how it actually built those connections, but there is no explainability. Why? I mean, that is it correct? Is my perception of your presentation is correct that you still cannot explain why those results? I mean that you find the spot, but there is no evidence or reason what is going on here.
So I can explain I can explain how we find the spot and why this is that spot that we need. I can explain how this attention hat is working, like how it is to what like tokens it attending to. But the problem in interpretability that you have to create the circuit and also you have to review the representations to understand the full picture. And it takes a lot of time, and a lot of researchers, they concentrate either on the circuits creation or either on the representations side. And then this combines to some like general knowledge when you have some specific circuits and you know that on this place a model creates the representations. So here I cannot say that this attention head it is actually writing the country into generation, but attention map it shows that it do. So I cannot show you the representation of what it is writing, but attention map is showing that it is doing that.
Okay, but you cannot explain at this point, or how can I say? So you started with this motivation example from this mayor case. And at this point, is it correct to say that we still do not understand how to change it, how to fix those factual incorrectness?
So we have methods that that are doing that. So they are
But I mean, you have, or like generally we as
general.
research, but you didn't work with those methods.
No, no.
Because of time limitations or what?
Yes, yes. We wanted to review those. We wanted to review that circuit and then apply the editing method to understand if the circuit changed or not and if we are intervening in the right place. But there was a lot of work with this interpretability, and we.
And can you get back to your conclusion slide, please? So what's this first point, create a data set? So you created your own data set?
Yes.
With those like prompts, right?
Yes.
Okay, see.
Okay, the first question is, am I right to understand that figure 3.1 is the most important in your work because it has like twice largest font and what is the very important, crucial importance of this picture?
It's not really like the most important one, but I wanted to explain this logic visualization well, and I wanted to show you that data is distributed, like it is. There's a data flow in the model, and I wanted to show that sometimes token probability generation it is promoted on the some components and then suppressed. So this shows like the complex behavior on the of the model, and that is why maybe it's so big.
Okay, in this context, what are your answers to the questions set at the in the very beginning?
So I don't believe, I don't trust the model's output, and I strongly advise you to cross-check everything that you read in the internet because you don't know if it like was written by the human or by the large language model. Um, but I do understand more about how this how model actually generate the information. And if this interpretability research will like grow and with other researchers, we can construct models potentially that will not be so dependent on the information that they get from the context, but they will be more strictly like advised to generate information from the model weights. And this is something that we can somehow control and somehow edit for now.
By the way, on the other hand, we remember the tool from OpenAI, which tells that every human-generated, truly human-generated text is like AI-generated. We remember this. Okay,
Yeah.
the next question is, can you please comment on the reviewer point about just a moment about is this result stick to GPT-2 only? Is it, or do you think is it transferability? Some
Um,
transferability.
so in terms of data set, yes, it could be used on the other models. In terms of the results, so in general, yes, general patterns could be transferred because in previous researches they say that, for example, induction heads they exist in GPT-2 and also in Llama 2, and yeah, but in terms of circuit, it will be probably more complex in the bigger model because there is a big influence of the superposition phenomena because we have like a lot of dimensions there, and yeah, so probably the circuit will be more complex, but like general approach might be the same.
Okay, I understand that the topic is about like interpretability, but I'm curious really about the real rationale of your work. Is it to hack the human brain or to crack the LLMs?
It's probably so. It's probably like mm, when you want to fix your car or, for example, any other mechanisms, you want to understand how it is working actually, because without that you cannot do anything. And this is like here. If you want to edit something in the LLM, we have to understand how the data is flowing, because right now we are like when we are training the model, we are saying like get us to that direction, and we are using the autopilot like the training method. We don't understand how actually the data is then going from the input to the generation.
But I hope you understand that
Yes, yes.
it's
There are a
it's
lot of
impossible.
great minds that are working on the interpretability stuff. So
Yes, and
I hope.
it's unreal to put it in any human brain. Yeah. Okay, thank you.
Yes, thank you for the presentation. Also, have a couple of questions. So, like in my understanding, this large language models may build some internal representations. So, for example, you have an input token that corresponds to the city name that then it goes to so many levels and it get transformed through multiple attention heads and so on and so forth. So somewhere in the middle of the models, there is, in my understanding, there is no token that corresponds to like meaningful semantic value, but rather their combination results like the interaction of token and weights. So how can we be sure that multiple of these interactions how can you backtrack to just one input token?
Yeah, that is a very great question. Um, yeah. So first of all, that you said about the representations, they are not completely like we are storing, as you said, a specific token. So how they do that in terms of, for example, for the residual stream, they are
But
doing
please be precise.
yeah. So they are doing the projection on the embedding space to understand where, in which direction this residual stream is going on. And in terms of attention heads, there are like this attention values to which token the attention attends, and the result could be also projected on the embedding space to understand the like some location.
I understand that, for example, this approaches to do a surgery of the large model are maybe first model specific because and also study data set specific. So, for example, do this approach transfer from model to model? And I don't mean that you get the same results, but at least is there signs of life that, for example, I perform the same analysis on a different model and I also find this attentions and so on and so forth?
Yes, activation patching, it is actually a simple technique, and it is transferable for the model to model because it only um, depends on the blocks. Attention maps, they are as well pretty good working on the llama. And yeah, but if you will run those methods, you will get the more complex circuit. For example, if you will run that on the bigger model. On the smaller model, you will get like the smaller circuit.
And I also Googled and I see that there are multiple methods, not only Rami. So why did you decide to stick to Rami only?
Because it is the first one, and it is the simplest one, and we try to understand what is back behind that. That is why we tried Romi and then switched to the interpretability, because we were really curious what is going on in the model.
And also I see that there is like a paper in 2023 called Easy Edit that studies knowledge editing, and also there is a paper, I guess, in 2024 called No Edit that does very comprehensive study of all the methods, including Romi, and they also list different data sets, for example, Wikidata, and they also established competitions. So can you have you like reviewed this work? Have you can you comment on?
No, we didn't review that work because at that time we were like more switched to the interpretability, and fact editing was left to the latest stages of the research. That is why.
Okay, and the last question, I understand that the topic of your work is large language model, but now language models also like support like visual information. So, for example, will these methods work if we uh, provide the model with the image, or is it only like text specific?
So I don't think that they are text specific, and I don't actually know how this visual information is encoded to get to the LLM. So this is something that we can left for the future work and investigate after.
Okay, are there any questions from audience?
Thank you for presentation. Can you go back to the slide with prompts? Yeah, so just coming back to your first question, can we rely on LLM's output? It seems that it might be beneficial for you to use like search third option for the prompt where you have controversial information. For example, when you use like in context some misleading information, but model should retrieve from factual like real information, and it might give the answer to your first question. So
Yeah, so we actually did that with our in context learning experiments. So what we did, we like stated that the city A is located in the country which the city is not located. So for example, in some imaginary country, right? And then we are asking the model about the city location, and model uh, often responds with the changed knowledge. So models are very perspective to what they get into the context. They actually like act as a one-shot learners or as a few-shot learners, you know that. And for our factual recall experiments, we like didn't mess with that changing the location, and this is how we get the pure picture.
and I think like in such a case, it will be interesting just to visualize also these attention maps when you want to confuse the model and understand how does it like.
Yeah, I have that. So actually, Point-a-Bit, it is located not in the Honduras, but I don't recall, maybe in Malaysia or something. And you can see here that this attention hat, it attends to the Point-a-Bit and then to the Honduras, like where it is like into the changed location.
Mm-hmm.
So it actually build some relations between those cities in the prompt and the changed location, and that is pretty fascinating.
Okay, I see. And I think like one more question. As I understand you, you were working only with models which are trained only in language modeling setup without like additional fine tuning with
Yes,
this.
yes, that's correct.
And do you have some intuition whether if we fine tune it with this RLHF like DPO or casual reinforcement learning approaches as OpenAI did, will it change the behavior?
Probably yes.
And
Probably yes.
like will it do you expect it will work like less like few short learner and rely on content on factual information, or it will be more biased to like to input?
So it depends. It depends what target we have. If you want to like fine tune the model to rely more on the context, it will do. If we want to make it more like stick to the inner weights, I don't think that it will have this opportunity to do it, because there are like specific methods that suppress the information in the context, and they are in the specific heads, and they probably should be like exploded to make it more stick to the inner weights.
Okay, thank you.
Can you go back like to your motivation?
Yeah,
Like,
sure.
second or third slide, like actually.
This one?
Yeah,
Or
so how did you solve like actually this task that you're spotting here?
so it is solved with the fact editing methods that we reviewed at the start of our work.
So the GPT for training will not cost like 100 millions, like no.
No, to edit a model, it's like really cheap.
But again, like editing a model is not the same as training model. So
Yes.
you would need like to train model in any case.
Yes, yes. To have a model, you have to train it, and then like you will.
But you're not like you're saying like this is motivation, but actually like the motivation is actually about wrong facts and not like about training the model.
Yeah, but I wanted to state that to train the model, it takes a lot of time and a lot of data, and retraining also takes time and money. So if you have to use like if you get to use the editing methods, it will be simpler and cheaper.
So can you also state like what is the result of your contribution? Because like on the second slide, actually you're stating like the other master students that are defending his thesis today. And actually it's not clear what exactly your contribution is.
So I did all the experiments and wrote all the code and derived all the results. So Nazari was helping me to understand more about how it could be applied for the bias, for example, or can we use the editing for the bias? It was some kind of that, and he also helped me to, I don't know, to structure the research in that way to that we stick to the interpretability and didn't like diverge into any other topic.
Okay, thank you.
Thank you all.
So let's move on. The next student is Natalia Volkova, and she will be presenting detection and analysis of manipulation techniques in news channels on Telegram in Ukraine. And she was advised by Alexei Ignatenko.
Alex, I'm sorry for the delay. I would like to present you my master thesis on topic computational detection and analysis of manipulation techniques in news channels on Telegram in Ukraine. The structure of my presentation is following. First of all, I tell you the motivation and research goal and as well the related work and their gaps. Afterward, I stop in research problem and approach to the solution. And after that, I will demonstrate you some experiments and discuss them. First of all, it is important to establish the clear understanding of the definition we used in our work. Disinformation is false information spread deliberately with the intention to mislead or deceive. And fake news is the category within disinformation, which is focused on media landscape, and it's potentially designed to false by fact or perception. If the fake news is deliberately created and dissemination with political agenda, it could be considered as a form of propaganda. It's the broad dissemination of fake news poses a threat to individual and society. The global impact was significant during such crucial event like 2016 presidential election or UK Brexit or the COVID-19 pandemic. And the Russian war against Ukraine underscores the urgency of automatical tool to detect the fake news, especially in social media. The pro-Russian channel disseminates the partial true or ideological messages directly to user using the social media. Analyzing contemporary Russian strategy of information propaganda, scholars like Paul Christopher and others identify that it contradicts the previously existing strategy of authoritarian regime that was focused on the one solely ideological oriented view of the situation and news consistently avoiding contradiction. Russian contemporary information warfare, on the other hand, it's seeks to sow confusion, propagates disinformation, rumors, and conspiracy theory. It's polarized opinion and instill distrust. So we focused in our work not on verification of the truthfulness of the news, but rather detecting the linguistic techniques deliberately used to twist the reader's perception and mislead them. The significance of identifying fake news or propaganda within news context has received increased attention, prompting research from a variety of different angles. Some of them focused on the document level only, whether the text contain disinformation or fake news or not. But other focused on the span level, and the first who proposed such approach were De San Martino and others. They created manually annotated corpus with 18 manipulation techniques. These techniques these techniques are really common in other disciplines, and this technique does not need external information for verification, for example, if the information is true or not. After when this corpus and approach was published, scholars proposed the variety of examples how we could tackle this problem, but only several of them was focused on the social media data. Majority were focused on the data from traditional newspaper. And we saw some gaps in these researches. First of all, they focused on corpora in English and Arabic, and it was more interesting for us to have this corpus of Ukrainian news. The second one, this corpora containing news text from from newspapers which are more structured. It is interesting for us to work with data from social network, which is more challenging and noisy. And also this task was not solved in Ukrainian language. And moreover, considering Russian information warfare against Ukraine, understanding the aim of the information techniques and their targets can be a valuable feature for our model. So, based on the research by Paul Christopher and others who have studied Russian information warfare strategy and tactics, we have selected 4 manipulation techniques out of 18, which is appeal to fear, doubt, lauded language, and black and white fallacy. However, taking into account the Ukrainian context, we did not want to work solely on these 4 manipulation techniques because some of them are very general, like doubt and lauded language. So we extended this 2 techniques more, and in sum up, we have 10 manipulation techniques, which is appeal to fear. And I will show the examples. The manipulation itself show highlight in red. Then we work with doubts in Ukrainian government, doubts in Ukrainian army, in efficiency and truthful of Ukrainian national media, doubts in partners' help, it could be other countries or international organization, and other doubts in Ukraine and Ukraine history, in refugees action, and so on. And also we worked with manipulation appeal to emotions, like appeal to anger, appeal to hate and disgust, and lauded language and other emotion. And the last class, but not least, it's black and white fallacy, when the problem is oversimplify and suggest only 1 or 2 possible options when much more are possible. So we want to develop approach to detecting fragments in social media new text with manipulative techniques and defining these techniques. For this, we need a corpus ideally labeled. So we prepare our data with following steps. First of all, we gather raw data, and then we built an annotation process. First of all, we scraped the list of news and media public channel on Telegram in Ukraine with more than 10,000 subscribers. In this raw data set, we have around 1,000 channel with more than 1 million posts. 72% of the text is in Ukrainian and 27% is in Russian. For the further step, we select only text in Ukrainian. And in this data set, we have 884 channels. Among them, 37 channels were in pro-Russian channels. The list of pro-Russian channels we selected based on research of propaganda Telegram channels by Chesna Center of Counter and Disinformation and Detector Media. For the data, and we select the data for annotation from this subset of Ukrainian text only. For selecting the text, we focus deliberately on pro-Russian channels to have more possibility to gather manipulation techniques. And in our data set, for annotation, we have 70,194 text. To ensure the accuracy of annotation, we wrote detailed instruction for each class. The instruction contained the definition of each manipulation techniques, the inclusive, exclusive criteria, common narratives, and examples. We used Labor Box platform for annotation, and 20% of our text will overlap to measure the agreement between annotators. First of all, we had the first step when 12 volunteers have worked with constant feedback to labeled our data. And after that, we have 66% of agreement between them. But then we apply the second step when two supervisors reviewed all text with manipulation techniques of 6 manipulation techniques out of 10, and the agreement increased to 90%. Overall, in result, the corpus contain 1,866 posts with at least one manipulation technique, among them 3,472 manipulation techniques cases. Our dataset is not balanced. As you could see that some classes have more instances. For example, the most frequent class is loaded language and other emotions, appeal to fear, doubts in government, appeal to anger, appeal to hate and disgust. And 5 classes have less than 110 examples. Also, we could see that the average length of the span of fragment of manipulation contains 29 characters. The shortest is the loaded language, which include swear words or exclamation. Usually they are short. And the longest is black and white fallacy. Usually it contains the whole phrases with 2 options. And that's why it's logically that it's so quite long. The examples of our label span. Span actually is a text fragment. It could be words, phrases, or sentences. Where the fragment belong to a manipulation technique in our cases, with technique name and position. Following the De San Martino approach, we have 2 sub-tasks, span identification task and technique classification task. First task is binary task, detect the span containing any manipulation techniques in a given plain text document. It doesn't matter what manipulation techniques is in this span. Therefore, before the process with model, we overlap annotations and merge spans which are overlapping. And the second subtask is multi-label, multi-class classification task. Classify what exactly manipulation techniques is used in a given span. In our work, we do not identify the manipulation span for this task. Example of span, here we could see that we have 2 spans and 2 techniques. And we proceed for both tasks, these 2 spans. But in this example, you could see that spans overlap. So for technique classification task, we use 2 spans separately. But for the span identification task, we overlap the spans and proceed as with one. The baseline for our task are following: the simple logistic regression and human level performance for span identification task. For human level performance, 500 randomly selected posts from the dataset for annotation were used for separate manual labeling. 7 volunteers which were not involved in the label process previously were provided with only the names of the manipulation techniques and the brief definition without further instruction and consultation. And for technique classification task, we use random selection, one of the 10 technique and most common represented class, which in our case is loaded language and other emotions. So the setup of our work is following. First of all, we split the data, then we pre-process it, clean the data, remove new line characters, multiple spaces, URLs, emojis, and converting all text to low cases. Then for span identification task, we merge overlapping, and we split text into sequences. For span identification task, it's binary task, and for technique classification, it's labels. After that, we tokenize our sequences in 128 maximum length and add special tokens in the beginning and the end of the sequences. This is the input for our model. We use the pre-trained BERT model, which is state-of-the-art for this task still. And we use it because it's bidirectional. It could read data from the beginning to the end and in opposite direction, which could allow us to grasp the relationship between tokens. The output of our model is embedded vectors with batch size 8 and with 768 hidden units. After that, we apply the classification task and get our classification binary or multi-class. We have deal with imbalance dataset classes. We deal it with two approaches. First of all, weights, and the second is synthetically generated text for 5 classes which have less cases in our data set. It's black and white fallacy, doubts army, media, partners help, and doubts in Ukraine. We wrote instruction for each class separately with separate examples, and we tailored prompts with list of who, what, how, and for some classes about what information. And also at the same time, we ask to identify the manipulative statement by token start and the end to have the weekly annotation data set. We have some limitation for this approach. First of all, we noticed that generated text often repeated similar phrases, words, or structure of the sentences. Sometimes it contained not only one manipulation techniques, despite we deliberately focused only on one. And it did not always correctly mark the beginning and end of the spans. Spans with manipulation techniques were quite long. As you could see, the average span length for it is 150 characters. But for in initial data for these 5 classes specifically, it's 54 characters. The results for our for span identification task is following. We apply the BERT with initial data and BERT with upsample data in train subsets, and this model overperform the baselines. Actually, the baselines how you could see have quite poor accuracy. But the model with initial data even have better accuracy compared to the model with upsampling. However, we have some drawbacks in both model. First of all, the model predict only one span per text. Whether you could see the ground truth data on the top, it's usually the 2 spans could exist. And it's interesting that the model with upsampling show a little bit better results on this parameter. And also the model predicts much longer spans than in ground truth data, and both model lack on these parameters. We also, for the sake of the experiment and for grasp the hypothesis for the further work, upsample the test subset. The reviewer mentioned that it is the great mistake. I agree that for the sake of just represent the accuracy results, it's not accurate, but we also would like to understand why the model perform this way. And you could see that that in the upsample data for both subset, we see that this generated text, they add some length for the subset. But we mentioned also in our master thesis that could be the data leakage due to the same pattern in generated texts. Overall, this span identification task is a really challenging one and needs to be proceed with the some additional effort to get more accurate result. The result for technique classification task is following. We used here F1 score for measure, and we could see that the result for the model with upsampling, with weights and without weights get the bigger result, and it predict much accurate, but it's important to understand why. And here you could see that that the model with initial data, despite the weight, failed to recognize the two classes with the fewest instances. But when we upsample it, regardless apply the weights or not, the model recognize these classes much better. Despite that, even the classes which were not upsample show the better results. It's interesting that the model still with initial data or with upsample, they could not they mislead the results for class appeal to hate and disgust, and it's because it's misclassify it as the class other emotion, loaded language and other emotion, or appeal to anger. And actually it's the limitation of all our models, that the emotional related classes misclassified, and you could see the on the right lower square that where this misclassification exists. And also all our models have another drawbacks for the overlapping span. Despite their full overlapping or partially overlapping, they predict always the same classes. Conclusion of our work is the following. We developed our own manually annotated corpus consisting of posts from Ukrainian news channels on Telegram, all in Ukrainian languages. For further work, we would like to publish this corpus for the sake of the NLP Ukrainian community. Second, our achievement, we do the first attempt to fine-tune a pre-trained BERT model to recognize the spans and their associated manipulation techniques. And we enhance the technique classification for technical classification task, the model performance through synthetically generated data. However, we have a lot of work in the future and have some suggestions. To overcome the prediction of longer spans by exploring the integration of both part of the speech and name entity embeddings. Also, the supervisor will conduct a review of annotation for emotional related classes to ensure the elimination of any annotation error. I remind you that supervisors will not checked these emotional base classes. But it will, even this step will not eliminate the whole problem with emotionally related classes. And we suggested separately identify and classify emotion first, like sadness, joy, fear, disgust, and anger, and then this information used as additional layer for classification task. And also improve the prompt techniques to get more variability, shorter spans, and apply the classification task separately. And also it will be useful to combine these both tasks together. So firstly, identify span and then techniques for this span as it's more practical. We have some limitation we consider only 4 manipulation techniques out of 18, but others could be also useful for this task. We worked only with text in Ukrainian, but text in Russian could have their own techniques and patterns which could be useful for our task. We aim to analyze only text data, but multimodal data like text with pictures or text with videos could be more insightful. And we don't not intend to draw causal inference that all manipulation techniques in the news channels on Telegram in Ukraine are spread by Russia, because there are some people with their own beliefs or with political agenda, but either way, it helps Russia in their informational warfare against Ukraine. And for the last slide, I would like to appreciate my mentor and the Mantis analytics team for their support and guidance. I am really grateful for volunteers who dedicated their time to label the data, and label box team for the free access to their platform. I thank my professor, fellow students, curator of the programs, and my husband for their support for this work. Without you and Armed Forces of Ukraine, this research would not be possible. Thank you.
Any questions?
Thank you for presentation and for your work. Yeah, but I think I have a couple of questions. Let's start maybe from dataset section. So you have shown the agreement, like overall agreement, but maybe you have explored agreement across across some of classes or maybe all of classes, because it seems that some classes might be pretty much obvious, while others, especially that contain others, might be harder to label.
Yes, it's true. We also did this work, and you are right that some classes are more challenging for volunteers than others. For example, the emotional-based classes is the challenging one because some volunteers misclassify the classes like appeal to fear and appeal to anger, or sometimes appeal to hate and other emotion are also not so quite clear. And also we came the conclusion in our appendix section of master thesis that it could be based on volunteers' background and information bubble in what they read and what they see, and probably next time when preparing such data set, it's useful to not work with volunteers with which were not educated in this task, but spent much more time on educate them, and probably gather more supervisors than volunteers.
Okay, I got it. Thank you. Okay, let's move to the next one. Yeah, when you formulate the task, you formulate it like in two steps, like span identification and technique classification. So am I correct that it is like your pipeline consists of two models, or it is like done by one model?
In our work, we tackle this class separately, not like one by one, but separately. And the model was run for span identification task separately to the technique classification task. But it, in the reality, it is much useful and practical to combine them both. But span identification task actually itself, it's quite challenging task. So it's you could stack only with that, because you could see that performance of the model is not quite great, and it is challenging to, for example, to have such result and only on this span to search what technique is used in this span.
But regarding this span identification, am I correct that it was like kind of casual name entity recognition approach, where you have like token to tag, like token to class, like sequence to sequence, let's say, task, or you were predicting like the IDs of the span? So like what was the output of your model for span identification?
Yeah, for span identification, it's binary task, like 0 if the fragment does not contain any manipulation, and 1 if the whole fragment contains manipulation.
Okay, so it was like label for the whole sequence, not
Yes,
for each
yes.
token.
Because in the before we pre-process the data, we split it, and actually I have. We split it. I have the example here for technique classification task, but the same is for the span identification, but in the label is 0 or 1, 0 for span with manipulation or without manipulation, and 1 for with manipulation.
Okay, so as if I correctly understand, on inference stage, you need to sample like lots of spans from the text, and then classify each span in order to find out like the span of interest, and then to classify it.
Yes.
But yeah, I'm just curious. So you have mentioned this work of fine grade, like fine grade.
Yes, fine granuated.
Fine granuated analysis of propaganda
Yes.
in news articles, and as I remember, they just do like classification of each token. So you like do this in a classical name entity recognition approach. Yeah, I'm just curious, why don't you follow like the approach to this task?
I follow this approach. What you mean? It's for technical classification.
I mean, like they first of all they do both tasks in one model.
Yes.
Like it is like the first point, and the second point that they classify. They do not sample like spans, but they classify each token. So for each token, you will have like some class label, let's say, which can be one of techniques or any technique. And in this case, you do not have to sample like spans. You just need one go through the text, which is much faster in inference. So.
Okay, I hear you, but I think that in this paper, which they published in 2017, they actually used the sequence classification. But I'll check.
Okay. Yeah, I think that I think that maybe the last question is about this additional data. So you mentioned that you have generated it with ChatGPT 3.5 Turbo, and I think there are two possible problems. First of all, that overall this version of ChatGPT may underperform in Ukrainian, but as I understand, you generated in English and then translate.
Yes.
Okay, and I think that the context of that were used for training is not very actual for the current situation. So have you checked if there are any domain shift of your generated data set and your data set of Telegram channels that you were used as a real data?
Do you mean domain like topic?
Yeah, like I don't think that ChatGPT 3.5 know about full-scale invasion, so like the topics might be different.
Actually, I give a specific topic on what it should generate the text. Sometimes I have the list of what topic it could choose. Sometimes this topic was the same like in Telegram, this text data. For example, there is no water. For example, the roads built the building of the roads, but sometimes the topic were quite generic, like ecology, parenthood, and so on. So actually it was really quite difficult to get the proper output from the GPT, which could have everything what I need. That's why I will see what we did more like rephrasing the text and adding some actors like journalists or government or etc. And add some specific actions. For example, media does not tell the truth, yes, about this topic, use the techniques like that. And it's more like rephrasing everything from different lists. It's not the best solution, but this synthetically generated text was more like to understand if the lack of the data is significant drawbacks for such model as BERT. And we could see in our results that actually even with this less classes, model still have some problems which could be tackled even without upsampling.
Okay, thank you. Yes, thank you for presentation. You have mentioned that your final solution is based on multilingual BERT-based model. And as far as I remember, this model was pre-trained on some kind of Wikipedia data, actually for a long time ago. Is there any specific motivation of not pre-training BERT on Telegram data that we have in very large amount, or at least using Ukrainian-specific BERT or Roberta Ukrainian by USCAN, for example, as an NLP model?
Actually, I use the BERT-based multilingual case because it supports Ukrainian, and there are no a lot of models which support Ukrainian particularly. I use it as the model which is quite popular and robust in other researchers, but I agree that some USCAN models could also apply at this work.
Okay.
Yeah, I also have a couple of questions. So first of all, I was surprised to see such a accuracy result. Could you please open it?
What task?
Yeah, so this table, so for example, the human performance only 6% accuracy, right?
But still, it's quite difficult task. If we see on the manipulation technique classes which we research, for example, if I told you find in this text black and white fallacy technique, which mean oversimplification of the problem, not everyone could understand what it means.
Yes, I understand that when we have multi-label, multi-class task, then accuracy is very like so very hard matrix. So would also be curious to see maybe like a binary classification, whether this has or doesn't have like manipulation, just to have a context of like how much harder this task when you have multiple manipulation techniques is like harder from just tagging whether this paragraph is disinformation or not.
But actually here on the span identification task, I use the human evaluation data, label data only for span identification task. It means that however they label the techniques, but here I use only the span, the beginning and the end of the token. So here it's the accuracy, how many letters they predicted the same as in manually labeled data.
Yes,
so even without technique.
I mean, this is kind of hard if they like miss the letters, then it's like false.
Yes.
So maybe you can come up with some softer metrics that can highlight. Okay, also. I'm curious how do these results align with the, for example, SOTA results that you mentioned that have been done in English?
It's not. It's difficult to compare because on the data set in English they worked only with 4 meta manipulation techniques. For example, appear to fear, blackened fallacy, doubts, and loaded language. Doubts, I have more doubts classes and loaded language. I separated it to separate emotions. And also it's quite not the apple-to-apple comparison, because if you could see, they have also in the data set quite little cases. So the result of their score could be not like the perfect one.
Okay, I see. Also, I'm curious about this training setup, given that you have a pretty... So what is the standard dataset size for example, that was used for training these models in English, and how it compares with your training dataset size?
Yeah, they use around 300 posts in my cases with any with one any of manipulation which could contain one of the manipulation techniques. I have 1,300 posts, something like that, and also I have. But they have much more cases. They have much more cases. If I'm not mistaken, they have around 5,000 manipulation techniques cases, but I have only 3,000.
Okay, I see. Thank you.
Okay, first I would like to say hello to Max Terещенко. Glad that the startup is useful in this context. The question is, okay, the first question is, can you please comment on reviewers' remark that you use artificially generated data in test set?
Yes, I mentioned that in the experiment purpose only, we also have we also have experiment when we upsample the test subsets as well, but we do it not to show the results like accuracy. It's definitely that it will be greater, but to understand, to grasp what's behind, to understand, probably we will understand the data and the model prediction better. But we agreed that it could be data leakage.
Okay. The next question is, do you agree that the task is absolutely practical, and application of these results is the very first question that would arise when you get not bad results?
I agree totally, but in what I achieved, it's actually not so great results on span identification task, and for aiming to develop some I don't know, application bot or etc. We need to deal with this task more precisely.
Indeed, my question is about, yes, your topic is like computational detection, so only about the model. But nevertheless, if you get a good model, how to implement it at scale, that everyone can understand that, okay, this is a manipulation, this is not.
But actually, we could follow as well this Martina and other approaches. They develop one-page site where you could add any news piece, and they underline which words or sentences could be manipulative and what exactly. And it gives actually the good transparency, because sometimes people, if you say that this piece of news contain manipulation, they could argue with you. But if you underline that, for example, this appeal to emotion which should not be in use piece, the person could agree it and perceive this information either to receive this news or, I don't know, to forget about that and do not read this channel.
Okay, great. But I never heard about this site. I'm interested in this topic, but I never heard about that site.
It's in English, and for English
Nevertheless, who knows about this site instead of you? And the next question about manipulation techniques. So as we truly understand, this is a classical word, for example, in SEO, so search engine optimization. So Google tries to make the algorithms more sophisticated, and like SEO engineers try to cope with this. So the same situation, manipulation techniques will become harder and harder, more sophisticated. And are you agree that your model just catches some patterns, and if techniques become more sophisticated, your model will will show worse results?
I'm not sure. Because actually manipulation technique and the tactics which use writer for manipulate the text, they are not changeable for some period of time. For example, if we consider this жах, що відбувається, it should not be in the news piece at all. And why the social media are so overwhelming with manipulation, because the channels, even the news channels, they allow themselves to public something like that. Even journalists which work in like national media, in social media, they allow yourself be more emotional and be more like catch the attention of the readers. And if I personally think that if society could understand these manipulation techniques and learn them by heart, they could see them in the news piece and be more resilient to the manipulation of their perception and their reality.
Okay, thank you.
Thank you for your presentation. Could you please go to your slide as far as I do remember, number 15 for the table? Yeah, this one. I spent about 40 to 50 seconds to understand what is meant in table. And finally, I just understood that that was a manipulation technique from you. Which kind of manipulation technique is presented here as an example?
Why do you think that it's manipulation?
That was the question for you. Just detect and explain what was the kind.
I am not aimed to manipulate you here, but wanted to present only factual information, statistical information of the data sets. And the first column is number of Telegram channels. The second is the number of posts in these Telegram channels. The third column is number of channels, pro-Russian channels.
It says number of posts in pro-Russian channels.
Oh, I see. This is, yes,
And
the
next table says the same. And
okay.
This is the manipulation technique.
I see, yes. Now I see it.
And which kind of manipulation technique did you use here unintentionally?
Hard to say. But the third column should be the number of pro-Russian channel. I'm sorry for my typo.
Okay, thank you.
No more questions. Thank you, Natal. "39 minutes break."